Floods are among the most devastating natural disasters, causing loss of life, property damage, and long-term economic impact. In India alone, thousands are affected every year. Urban flooding is not just due to rainfall, it is caused by how cities are built, reduction in natural drainage, increase in impermeable surfaces, encroachment of floodplains, and inadequate stormwater infrastructure. In this study, we assess flood risk for a proposed urban development project using advanced hydrological and hydraulic modeling. The modeling begins with generating a digital elevation model, which represents the terrain and elevation variations of the site. This is the foundation of flood simulation. The terrain is processed to remove errors and to define flow paths and drainage patterns. Next, drainage channels, natural streams, and stormwater paths are defined, including cross-sections and flow geometry. Rainfall data is converted into runoff using hydrological methods, generating flow hydrographs for different storm scenarios. Boundary conditions, such as upstream inflow and downstream water levels, are defined to simulate real-world conditions. A 2D computational grid is created, allowing water to flow dynamically across the terrain. The model is then executed, simulating how water moves across the site during rainfall events. Results show flood depth, extent, and velocity, highlighting no flood risk within the project area. Based on the modeling results, the project site does not exhibit significant flood vulnerability, and no major drainage bottlenecks were identified. Based on the results, mitigation measures were proposed: improved drainage design, elevation correction, rainwater harvesting systems, and permeable surfaces. Flood modeling using HEC-RAS enables data-driven decisions, ensuring safer and more resilient urban development. Don't wait for floods to happen. Model, plan, protect. Contact us for comprehensive flood risk assessment and HEC-RAS modeling solutions.